Okay, dear students, we are going to start a new chapter called integrals. Okay, differentiation we have completed to last class. Complete differentiation, differentiation, application of differentiation, all we have completed. Okay, then we are starting um, integrals. That means integration. What is integration and all we will understand. But you see, unless we know differentiation thoroughly, we are not able to do this integration. That is why differentiation is a must for integration. Okay, from differentiation only we are going to study the integration. Okay, what is integral? What is differentiation and derivative? Like integral and integration. Okay, terms are, you see, I am writing here. You see, derivative, differentiation. Okay, equivalent words are derivative, integral, differentiation, integration. You understand? Derivative, integral, differentiation, integration. We know derivative, what is differentiation and that. Okay, we will see what is derivative and differentiation, how to do simple ones. Okay, we will see, we will write d by dx of y, or else we will write d by dx of f of x. Okay, you see here, d by dx of x square will yield 2x. Okay, here you see f of x is equal to x square, f dash x is equal to 2x. First you understand this. That means this already we know. Differentiation y with respect to x. Differentiation of f of x with respect to x. Both are same. Y is equal to fx. Okay. Differentiation of x square with respect to x gives 2x. Here f of x is ry, or else we can say like this also. Y is equal to x square, y dash is equal to 2x. All are okay. Different types we are going to call. Okay. D by dx of y or d by dx of f of x is equal to d by dx of x square. That is equal to, this is the result, 2x. Here dx is in denominator, you see, with respect to y, because see, rate of change of means always it will be in denominator. Okay. F of x is equal to x square, but f dash x has come to x. F of x is equal to x square, but f dash x has come to x. Y is equal to x square, but y dash is equal to 2x. Okay. See here, derivative we are finding. The process of doing this is called differentiation. Okay. What is the derivative of x square? Means 2x. The derivative of x square. Find the derivatives for 2x square. That means derivative is 2x, like we write it. But the process of doing this derivation is called differentiation. Differentiation. Now, what if they give f dash x and ask us to find f of x? F dash x is equal to 2x, and they are asking us to find f of x is how much? Simple logic. See, unless you don't know the differentiation, you are not able to do the integration. That's what I am telling. Okay, integration is based on differentiation only. Integral is based on derivative only. Okay, that means derivative of 2x. So how derivative comes of final output 2x, like we have to see. See here, 2x is there. Then you have to think in differentiation how 2x is going to come. Okay, if you see, if anything is there in power, then that will come x into n power n minus 1. d by dx of x power n is equal to n into x power n minus 1. Two x is there means x power 1. 2 into x power 1 is there here. 2 into x power 1. 2 into x power 1 is there means you have to think, oh, how it is coming. Okay, it may be x square, then 2x will come. Like that you will think. That means f of x is equal to x square. Like that you will think and write. If f of x is equal to x square, then f dash x is equal to 2x. F dash x they ask us to find x square in integral. Okay? That means you are finding the process but going reverse. The process is called anti-derivation. The process of anti-derivation is called integration. You understand? Differentiation or derivation, derivative, integration or integrals. Okay, these terms. That means if you want to find the derivative, then you have to go back. Primitive, like we can say. Derivative already they have given. Primitive you have to find. That means anti-derivation you have to do. Reverse process. Here x square is 2x, but 2x again you are going to bring back x square. That is called anti-derivation. You see here some symbol is there. Integration is called anti-derivation, that is okay. But how to show? Here we are showing d by dx of x square, d by dx of y. Or else we can write d by d theta of also. You see, like this also we can write d by d theta of sine theta. Why? Because theta, with respect to theta, we are going to do the differentiation or derivation. Okay? But here, what is the symbol? You see, elongated S is the symbol. You see, elongated S with dx. Why? Because here dx is in denominator, here dx is in numerator. Why? Because dx means dvx by 1 is there. Like that you have to think. Okay? Integral dx. That means same thing if I want to write, how can I write? You see what I am writing now. Integral 2x dx is equal to how much? Why? Because see here, integral and dx both are must. If it is not dx, then it may be d theta. If it is not theta, it may be some other thing. Integration of 2l with respect to 2l. Integration of 2 theta with respect to theta. Integration of 2x with respect to x. Okay? We can say here 2x is f dash x. Okay? See, because you know here x square is there, that is why you are calling it as f dash x. Or else you can say simply f of x also. F of x also. But we are thinking only about integration. Then this is called f of x. Okay? See, 2x or f of dash or x, something is called integrand. integrand. X is variable. Okay. X is variable. 2x is called integrand. Okay. See, you may ask, is there any formula like? See, we will analyze one formula. We will analyze. Why? Because see, for only x power n we can analyze one formula. Remaining all you have to take from what we can say derivatives only. Sin, cos, tan, all 17, 18 are 14, 15 are there. Okay. You see what I am writing? See, in differentiation, d by dx of x power n will yield n into x power n minus 1. Is it okay? Okay. Based on this, d by dx of x cube will give 3 into x square. Is it okay? N into x power n minus 1. Okay. Same thing we will do here. Then we will find one formula. Formula means result or whatever it may be. You see here, 3x square has 3x square you are doing, but x cube has to come. That means you see what I am writing. Integral 3x square dx. If you do, x cube has to come. Okay. How will come? How to send? If you send back again, it is going to become 6 there. Okay. You see here logic. I will write 3 like that only. But what I do, 2 plus 1 divided by 2 plus 1 I will write. Okay. Then what will happen? 3x cube by 3. 3 going to get cancelled. X cube will come back again. Is it okay? If I want to write like this, then what will be the formula? See here. Integral x power n dx is equal to, see this d integral symbol and dx is must. You understand? Is equal to x power n plus 1 by n plus 1, where n is not equal to minus 1. Sorry, not equal to. If it is equal to minus 1, automatically what is going to happen? 0 will become, divided by 0 is going to become undefined. Okay. That is why you should keep in your mind, n should not be equal to minus 1. If at all n is minus 1, that derivative or integral is separate. Derivative and integral both are separate. That we will see. Is it okay? First we see. We have not derived anything. See, no, there is no derived what we can say items or formulas, results in integrals. You have to take from differentiations only, derivatives only. These derivatives only you have to convert like this. Rather we can say we will convert, that's all. Okay. Here we have converted. You see, x power n, if you wants to come back again here, then you have to apply x power n plus 1 by n plus 1. Then only it will come. You see, I am coming back to this one, n into x power n minus 1 they have given. You see, integral n into x power n minus 1 dx they have given. Okay. See, I am going to get again x power n. You see how I am getting. That is equal to n into x power n minus 1 plus 1 by n minus 1 plus 1. N plus 1. N plus 1 means here n minus 1 is n. Like that you have to think. Okay. See, minus 1 plus 1, minus 1 plus 1 going to get cancelled. And n going to get cancelled. Finally, x power n you are going to get. Okay. That is why for differentiation d by dx of x power n is equal to n into x power n minus 1. For integration x power n dx, integral x power n dx is equal to x power n plus 1 by n plus 1. Okay. Like this you have to see. Okay. See, I also told what is integrand. This is called x power n is here integrand. X is variable, and this is elongated symbol along with dx. You have to write. Okay. See, two properties we will see. Two properties. See, all we are seeing by comparing with differentiation only. Two properties we will compare with differentiation, and we will draw two properties. Then we go for standard integrals. Standard integrals like standard derivatives. How we have seen. 16, 17, 15 are there total. Sine, cos, inverse, x power n, root x, 1 by x, log x, e power x, a power x, all we will see. Okay, we will see. But see, we are not going to derive those integrals. We will write a derivative, then we will see what will come. Okay, why? Because see, if you make antiderivative, that result has to come. Like that we will see. Okay, let us go for a simple two properties. We will see properties of integrals, but we will write here in property of different derivative, and we will compare with it. Okay, then only we will get easily. Okay, we will see in differentiation if two functions are there, f of x and g of x, or we can say u is equal to f of x, v is equal to g of x. Then you see here d by dx of u plus v, that is equal to d by dx of f of x plus g of x is equal to what we are going to write here, d by dx of f of x plus d by dx of g of x. Is it okay? Or else also we can write d by dx of u plus d by dx of v, du by dx plus dv by dx. Here u or v is not constants. U is equivalent to f of x, v is equivalent to g of x. If w comes means f g h, h of x, like that. Even h comes also, u plus v plus w, f of x plus g of x plus h of x, d by dx of u, d by dx of v, du by dx plus dv by dx plus dw by dx. Like that we will write addition or subtraction. It may be subtraction also. Okay? Okay. What about the case of integrals then? All we study by comparing differentiation only. This is differentiation. Okay? See, f of x, g of x is same. U or v also same. Integral, what we are going to write? We are going to write like this, is equivalent. Integral f of x plus g of x dx. Okay, integral symbol and dx both should come. You take a little bit bigger, elongated s is equal to same integral f of x dx plus integral g of x dx. See here, what is the logic? When you are doing integration, not thinking in mind of differentiation, here this is f of x and g of x. But when they give differentiation, then this is going to become f dash x. Why? Because see, when you are adopting for integration, this is the function. Okay, for integration, this is the function f of x. If you go back to differentiation, for differentiation, this is the function. After differentiation, f dash x will come. Okay, like that you have to keep in your mind. F of x plus g of x. Shall we write like this also? You see, that is equal to integral u plus v dx is equal to integral u dx plus integral v dx. Is it okay? Why? Because u, v are f of x, g of x. U and v are not constants. Okay, this is one property. Note down. Another property also we will see. Multiplication. See, this property you can write addition and subtraction like. Okay, addition and subtraction. Another property we will take multiplication with constant. Okay, let us see that also. So another property is multiplication with constant. Say k. Multiplication with constant k. See, multiplication with constant k, not differentiation of multiplication or differentiation of integration. Differentiation of constant is 0, that we know. Okay. Okay, we will see here multiplication with constant means, see, d by dx of 2x is equal to 2. Is it okay? D by dx of 2x is equal to 2. D by dx of kx is equal to k. We don't know this k. What is that k? Okay, d by dx of kx is equal to k. Or else d by dx of cx is equal to c. We will use c. Why? Because c we are going to use universal constant. Okay, come back here. So this equivalent, this multiplication with constant, that means see, with multiplication with constant, this is not like d by dx of 4. This is 0. Constant will not come. Constant will not come. Okay. What if d by dx of kx square, 2kx will come. That means this 2 is differentiation normally will come, but 2 into k, always k will come. Differentiation. Okay. This is the theory part we learn in the differentiation. Okay. Equivalent we will see in integration. We see here integral to dx. Integral to dx. Is it okay? Why? Because 2x is f of x, 2 is f dash x. We are doing here integral to dx. This is equal to how much it comes? 2x only. Then how it is coming? Here x is not there, how x has come? What you have to do, see here, that is equal to 2 integral dx. Constant you have to take it. Then integral dx is equal to x. How x has come? You see here. D by dx of x is equal to 1. Dx by dx. Then integral 1 dx is equal to x has to come. Integral 1 dx or integral dx, both are same. You understand? See, forget about 2kc or something. Even simple integral dx should yield x. Simple d by dx of x will come 1. Simple integral 1 dx will come x. That is why integral 2 dx means 2x. Integral k dx means k. Sorry, kx. Integral c dx means cx. Understand this? Okay? This is multiplication with constant integral. Here differentiation, and here also you see one more thing I will write. Integral 3x dx. 3 integral x dx. 3 x square by 2. But because here x power 1 is there. X power n plus 1. 1 plus 1 by 2. X square by 2. That means here 3x square by 2. That's all. 3x square by 2 will be the answer. If 3x they give. Okay. But see, differentiation how it comes? 3x d by dx of 3x square by 2 is equal to how much? 3 by 2 you take common. X square means 2 into x power 1. Then 2 going to get cancelled, 3x will come. This 3x you are doing here, integral 3x. Integral 3x if you do automatically 3 by x square by 2 will come, 3x square by 2. Okay, this is the logic you have to understand. Okay, okay, and okay, you see now multiplication rather than with constant, multiplication of constant, sorry, derivation of constant is how much? See, we have seen just now integration, addition, subtraction also, integration also, differentiation, integration. F of x, g of x is there. What we do here, d by dx of 2x plus d by dx of 3, like we will take. But in brain itself we do it, this one directly. But like this you have to take as per procedure. D by dx of 2x is 2 plus d by dx of 3 is 0. Why? Because constant doesn't have any change in derivative. Rate of change will not be there. Change will not be there. That is why rate of change is going to become 0. That is why this is going to become 0. Okay. Then what if here integral? Come back here. Integral 2 dx is equal to 2x. But what about this 3? 3 will not come. That is why you have to write C. Why? Because you don't know. That is the procedure. Better you take like this. Integral f of x dx is equal to any one value will come, but you take C also. Okay. This constant you take. Why? Because this constant we don't know. This constant may be 3 or something. In special cases, they give some hint or some, what will you say, possible finding. At that time you can find, or else you are unable to find this. But you have to write constant is there. That constant may be 0 also. If any constant is not there, then C is going to become 0. C may be 0, negative number, positive number, whatever it may be, C, constant. Okay? Like this you have to understand concept. This C should come for all integrals. Now we will go for standard integrals. Okay. Let us see standard integrals, but with standard derivatives only we are going to write these integrals. We are not going to derive standard integrals. The standard derivatives we have already derived in a differentiation. Okay. Each and all we have derived. Okay. Now let us see one by one. First one itself, the simple one, d by dx of x power n is equal to n into x power n minus 1. Okay. This will be for differentiation. Equivalent of this how to find? Integral n into x power n minus 1 is equal to x power n, we easily you can write. But I want to write integral x power n. Integral dx we have to write in between x power n, that is equal to x power n plus 1 by n plus 1. Is it over? No, you write plus c also, constant, because it is a good practice. Why? Because see, here you don't know, see x power n has come, but x power n you don't know whether it may be x power n plus 3 also may be there. Okay, plus 3 also may be there, but this 3 has become 0 here while differentiation. What I mean to say here function, some function, see, final result has come, that is okay. But here you see here x power n plus 3 is there. What you are going to write? N into x power n minus 1. That's all. Plus 0 you are not going to write. Plus 0. But you are giving this for differentiate derivation. This is d by dx of. Final result has come. See here, f of x is equal to x power n plus 3. But f dash x is equal to n into x power n minus 1. Why? Because 3 has got 0. What you are doing here? Integral f dash x you are doing to. Then what you are going? Integral n into x power n minus 1 dx you are doing. Then finally you are getting x power n only. But what about 3? For sake of 3 you are writing plus c. Okay? Why? Because see, this 3, how much constant you don't know. That is why you write constant c. That's all. Okay? That is a good practice. Okay. One by one we go. Number 2. You see, I am not writing in standard, but we will analyze d by dx of x is equal to 1. 1. Okay. Integral dx is equal to x. Why? Because here 1 into dx is there. Okay. Another one also, important one. You see, these don't take in standards. Okay. This you have to keep in our mind. Because this is logic. Dx by dx is 1. We know. And integral dx is equal to x. X plus c you write. Why? Because see what I want to say here, x plus 3 also may be there, t by dx of. At that time here only 1 will come. But if you do differentiation, only x will come. What about 3? For the sake of 3 again you have to write x plus c. Okay. Another one. You see, d by dx of root x, how much it will come? 1 by 2 root x. This we know very well. X power 1 by 2 you take. And 1 by 2 x power 1 by 2 minus 1, that is equal to 1 by 2 x power minus 1 by 2, that is equal to 1 by 2 x power 1 by 2, that is equal to 1 by 2 to root x. This much procedure is there. That is why simply we remember that d by dx of root x is equal to 1 by 2 root x. Why? Because this much of calculation again and again we don't do. We write it directly. What if integral x? Integral root x? Simply you write x power 3 by 2 by 3 by 2. That's all. After plus c. See, this 2 by 3 is going to become 3 by 2 is going to become 2 by 3 into x power 3 by 2. See, several way you can convert this. How can I convert? You see, 2 by 3 into x power 3 by 2 is one thing. 2 by 3 into root x whole cube one thing. Power 1 by 2 is root x power 3. To avoid all confusion, what we write? Integral root x dx is equal to x power 3 by 2 by 3 by 2 plus c. Okay. These two I am not adding in standards. Okay. Remaining we will go again. Okay. Okay. Let us go for trigonometry. D by dx of sin x. Cos x. Okay. D by dx of sin x is cos x. What about d by dx of cos integral cos x dx? Integral cos x dx is sin x. Okay. Then come for d by dx of cos x. minus sin x. Or else if I write d by dx of minus cos x sin x, is it okay? First you see, you compare both of these. Why? Because see here d by dx of cos x means minus 1 into cos x like you think, and minus 1 you take common, d by dx of cos x minus sin x will come. Finally minus 1 into minus sin x is going to become plus x sin x. This logic applies in integral also. Okay. See, integral normally minus we don't write even like differentiation. You take out common like. Okay. Here also you see d by dx of cos x is equal to minus sin x. What I write you see, integral sin x dx is, you see plus c how to write, I have forgotten, minus cos x plus c. Simple sin x if you take minus cos x plus c. You understand this? You may ask, sir, why can't I take minus sin x? That also you can take. That is not wrong. You see, integral minus sin x dx also you can take. But finally what you are going to do? Minus 1 you are going to take common. Sin x dx you are doing. Finally minus 1 common will be like this only. But minus cos x plus c will come. Minus of minus is going to become cos x plus c. If you take minus cos x, if you don't take minus, then minus cos x. Both are correct. Okay. But when you write in standard form don't write minus here input. Whatever may be the output, it will come. That is different. Okay. Here also don't standard don't write minus. You write only cos x. Minus result will come. Okay. That you have to understand. Okay. Here I will remove this. Here I will remove it. Understand this? Here d by dx of cos x is minus sin x, but d by dx integral sin x is equal to minus cos x plus c. Plus c is a must. Plus c is a must. Let us go fourth one. D by dx of tan x secant square x integral secant square x dx tan x plus c. Why that plus c? Here tan x plus constant also will give secant square x only. That constant is going to become 0. That is why secant square x means tan x plus c you have to write. Okay. That means tan x plus c, some other constant may also be there, like we are telling. Like that. You see, you might got one doubt. See, d by dx of, see, in differentiation for sine, cos, tan, all are there. For integration, sine, cos, okay. But what about tan? Simple tan. Those are also there, but we will do it afterwards. Why? Because for coming to that stage, we require more knowledge, multiplication of integrals and all. We have seen only addition, subtraction, and with multiplication with constant only. In future, we will see multiplication of integration u into v, u by v. Why? Because those are required. Sine by cos, like that you have to take. Then only those results are going to come to you. Okay? We will do it afterwards. Integral tan x, integral secant x, like. Okay? Now integral secant square x only you are going to get. Present exercise. Okay. Now go for cot x. D by dx of cot x minus cosecant square x. Is it okay? Cos minus cot minus cosecant minus will come. Co means minus will come in differentiation, not in integration. You see here, in integration cos plus has come, integration, but here sine also minus has come, sine minus has come. But here what will come, you see? Integral cosecant square x dx is equal to minus cot x plus c. Is it okay? Minus we are not going to write. Even if you write minus also not wrong. If you write minus here, cot x will come. This minus cosecant square if you write, cot x will come. But if you write rather than minus only cosecant square x, then minus cot x will come. That's all. You understand this? Integral cosecant square x is equal to cosecant square x is equal to minus cot x plus a c. Okay, Here see, for a differentiation d by dx CO minus has come. If not CO, that means cot, cosecant, cos plus C will come in differentiation. But here integration there is no, that logic will not apply. CO plus has come, CO minus has come. Okay, how purely depends on these results, derivative. Unless you know, unless you thorough in this differentiation results, standard derivatives, then you are not going to get standard integrals. That is the logic. This is logic only. Here, why? Because see, integral is the antiderivative. If your derivation having symbol minus, automatically minus will come, irrespective of this cot or cosine or whatever it may be. Okay, that you have to keep in mind. Let us go for remaining. I am removing and I am writing from 5th over, 6th onwards. 5th cot we have over. Sin, cos, tan, cot. Secant. Write down secant 6th. D by dx of secant x is equal to secant x tan x. Okay? Integral secant x tan x dx. See here, you need not keep parenthesis or bracket. Why? Because all are multiplication. All are multiplication means, see, cosecant square x dx means cosecant square x into dx, like you can think. You need not keep any bracket or parenthesis. If it is secant x plus tan x means better you keep parenthesis. Why? Because this dx will apply for secant x and tan x separately, like we have to tell. Now see secant x tan x, what will come? Secant x will come. Secant x plus c. Here also you should get one doubt. Sir, d by dx secant x is there, but what about integral secant x? That also is there, but not now. That secant x you have to do 1 by cos x, like you have to take and you have to do, but that will come after integration further. What we can say, now we are in starting exercise or starting stage. Multiplication, division, there you will get, in terms of log are going to get log cos x, log sin x or something like, let it be, whatever it may be. But until now standard derivatives only we are doing. That means what we can say, standard derivatives are less but standard integrals are more. That we can say. Standard integrals are more, but not in this class. Afterwards we will learn further. As per standard derivative, secant x is equal to secant x tan x. Integral secant x tan x is equal to secant x plus c will come. But what about integral secant x? That also will be there. Integral tan x, that also will be there. Okay? Okay. Write down. Next step. 7th. D by dx of cosecant x minus cosecant x cot x. Is it okay? Cosecant x minus cosecant x cot x. Integral cosecant x cot x dx is equal to, this minus we don't take here, but we will write minus this one here. Minus cosecant x plus c. In a result will come. automatically see d by dx of cosecant x minus cosecant x cot x. This minus, if here it is there, here you don't write minus. If minus here not there, here you write. That's all. Okay. I'm removing this. No, I don't require this. Okay. Now, okay, all over not standard, normal trigonometry, but inverse we have to go. Okay, sine, cos, tan, cot, secant, cosecant over. Then d by dx of sine inverse x we will take. One by square root of 1 minus x square. Is it okay? Sine inverse x is 1 by square root of 1 minus x square. Then you write integral this. Is it correct? First you see. Why? Because integral 1 by square root of 1 minus x square into dx, if you write it, dx is going to multiply with 1 only. That is why directly I have written dx by 1 minus x square under root integral. Both are same, na? Then you write sine inverse x plus a. Okay? Go for cos inverse. Minus 1 by 1 minus x square under root. This is plus 1, this is minus 1. Sin inverse x is minus 1 by square root of 1 minus x square. Cos inverse x is minus 1 by square root of 1 minus x square. But do you write here? Minus 1 integral. Normally we don't write. Same we write, but this you have to write. See, if here minus is there, here we minus keep. Minus cos inverse x plus c. You understand the logic here? If you want, you can write minus here also. You see, simple logic. Equal to is there. Here equal to is there. If you multiply with minus 1, both sides you will multiply. Okay, you may ask me, sir, constant also going to become minus. See, constant we don't know, it is a minus or plus. Why? Because cos inverse plus constant also will give plus c only here. Cos inverse minus constant also you are going to write minus c only. Okay, that is why we are telling. Constant plus c we are writing, but we don't know that constant. Constant may be minus 3. Constant may be minus 100 here. Here I am talking about. Here we don't write that constant. What is there? We don't know. If you multiply with minus 1, minus 1 by 1 minus x square will come. Here plus cos inverse x will come. Same thing is there here. That means for inverse integrals derivatives, you can simply change. If you want to change sin inverse x as cos inverse x, you simply put minus. Minus cos inverse x. Cos inverse x as sin inverse x, you simply put to minus. Minus sin inverse x, like that. Okay? You understand this? Okay? Let us go for sin cos tan inverse x. One by 1 plus x square. D by dx of tan inverse x is 1 by 1 plus x square. Then you go for integrals. Dx by 1 plus x square. Why? Because 1 into dx is equal to tan inverse x plus c. Why that c? Here tan inverse plus 3 also will give same 1 by 1 plus x square only. That 3 is going to give 0. Tan inverse minus 6 also gives same thing. That is why plus c we are writing, but that c constant may be minus plus 0. If nothing is there, 0. Okay? tan is over. Then we go for cot. D by dx cot inverse x minus 1 by 1 plus x square. Is it okay? Minus 1 by 1 plus x square. Then shall we write here integral minus 1? No. Minus cot inverse x. Is it okay? Why? Because see, you can multiply with minus. Minus 1 by 1 plus x square is equal to minus is going to become cot inverse x. Minus 1 by. That is why. You see here, both are same. You can write tan inverse x or minus cot inverse x. Whatever way you want, you can write. Okay? That practice also you have to do. Okay, now I am going to remove this. Secant inverse x. One by x into square root of x square minus 1. Is it okay? 1 minus x square is for sine, x square minus 1, but again multiplication of x will give secant inverse x. Okay, write down integral dx by x into x square minus 1 secant inverse x plus c. Is it okay? X into square root of c x square minus 1 secant inverse x plus c. Cosecant inverse x. Minus 1 by x into square root of x square minus 1. Cosecant inverse x. For cosecant inverse x, minus will come. For secant inverse x, minus will not come. But here what you are writing? You are writing same. Dx by x into x square minus 1 only you are writing. Minus you are not writing. Here you are writing minus. Why? If you want to minus 1, you can multiply. Minus 1 by x into x square is equal to minus if you multiply cosecant inverse x. If here minus comes means. That means for only one result you can write secant inverse x or minus cosecant inverse x. Okay, now trigonometry over. Then we go for e power x, log x, a power x. Three are there. First we see log x. Is it okay? d by dx log x is equal to 1 by x. Integral 1 by x dx is equal to log x plus c. Why? Because here log x plus c also will give only 1 by x only. That c is going to give 0. That is why c we have to write. Okay. Now one important observation you have to see here. I have already told n should not be equal to minus 1. Like you see here, if you want to take this as a normal integral, x power minus 1 dx will come. This will give x power minus 1 plus 1 by minus 1 plus 1. But see, numerator is okay, x power 0. But here 0 will come. That should be careful. Always I told n is not equal to minus 1. That is why integral 1 by x dx means log x plus c you have to write. Okay, this is very important result. Understand this? Okay. Then one easy simple e power x we will write. Is it okay? d by dx e power x is equal to e power x. Then whatever e power x dx, integral e power x only. Okay. You should be very careful for log x. In log x also, 0 also we don't give, less than 0 anyway we don't give, 0 also we should not give. X is always greater than 0. Then only it is going to become valid. Or else it is going to become undefined. X 0 also should not come. Greater than 0. Less than 0, 0 should not take. X is greater than 0. That's all. Okay. Here d by dx e power x is equal to d power x. Integral e power x is equal to d power x. See, based on e power x, we will let a power x, that will be last for this class. D by dx of a power x is equal to a power x into log a. This we know very well. Okay. Why? Because see, both sides log x you have to take. Y is equal to a power x. And differentiate to both sides like that. If you take, then this will come result. We know very well how we did this. Y is equal to a power x. You apply log y is equal to log a power x. Then log y is going to become x log a. Log y means what? Differentiation. 1 by y dy by dx is equal to C log a into d by dx 1 plus x into d by dx log a 0. Okay. Finally it is going to become log a. But you see here 1 by y dy by dx is equal to y log a. Then what is y? Y is a power x. That means you are going to write a power x log a. Why you are not writing like this log a into a power x? Why? Because anyway log a is constant. Like 3x, why you are not writing? Why? Because you are going to get confusion. A into a power x means you may take log of a power 1 plus x. That is why we should not write like this. A power x into log a only how to write. Yeah, this is the story for d by dx. Okay. A power x log a. You see, for integral a power x log a will not come. Okay. For integral a power x dx only will come. Like d by dx a power x. Then how can you write that? A power x log a comes means you can write easily a power x. But only a power x comes means a power x by log a plus c, how to write. Okay. You see, a power x by log a, if you give automatically, you see, a power x log a comes means automatically a power x will come. A power x comes means a power x log a. This you differentiate now. D by dx of a power x by log a is equal to, see, 1 by log a is constant, you take out 1 by log a into d by dx of a power x. Then 1 by log a is constant. A power x log a means a power x into log a. Log a going to get cancelled. A power x you are going to get a power x. Okay, like that you have to think. Okay, see here multiplication is there. Here division will come. To cancel out each other. We do one thing, we stop this class here and next class we will continue, and I suppose next class we can do exercise also. If require 1 or 2 examples we will see. After examples we will go for exercise, or else if examples are not required directly we can go to exercise, then we will go to exercise 7.1 and we will continue. Why? Because whatever the theory we wanted to learn we have seen. Okay. Thank you very much.